Hello, everybody, and welcome to the Geoscience Australia public seminar for this Wednesday, the 6th of November, 2024. My name is Dr. Steve Hill. For those that don't know, I'm the Chief Scientist at Geoscience Australia. Before we go any further, I just would like to say that Geoscience Australia acknowledge the traditional owners and custodians of country throughout Australia and wherever you may be calling in from across this great land. And we acknowledge the continuing connection to land, waters, sky and community that these people have. We pay our respects to the people, the cultures and the elders past and present. And it's a really important thing for us to be doing that here at Geoscience Australia, because our science is so integral to connection to that country and how we integrate and live with and work with the traditional owner knowledge is a really important part of that as well. Thank you for those that are joining us, both from within Geoscience Australia, but I know that these seminars are a great way to also bring in and expose our science to a range of people from outside of Geoscience Australia as well. Today, we wrap up the Geoscience Australia Wednesday public seminar program for 2024. And we do that with the Positioning Australia Digital Showcase, which will explore the program's achievements and future plans. Leading us off with this will be Dr. Martine Wolff, Positioning Australia's branch head, and she'll step us through the program and what's included as we go through that today. Just a little bit of background on Martine. Amazing person, as we all may know, but she's got a great background too. So Martine is leading the team delivering Australia's next generation positioning capability, and she's worked in a variety of roles in Geoscience Australia since 2011. Prior to coming to Australia, Martine worked in the private sector in the United Kingdom for a global risk management consultancy. Martine has a PhD in environmental systems science from the University of Reading in the UK, and an MSc and BSc from Wageningen. How did I go, Martine? Passable, yeah. Agricultural University and Research Centre in the Netherlands. Please join me in welcoming Martine, and I'll hand over to her. Thanks, Martine.
Thank you so much, Steve. Just checking, can you hear me? Not on mute? Okay, thanks very much. And really pleased to be able to close this seminar series for Geoscience Australia with what I'm hoping will be an engaging and entertaining showcase that really showcases and highlights the benefits that Positioning Australia, a transformational program, brings in terms of delivering accuracy and reliability for positioning in Australia. And like Steve, I would like to acknowledge the traditional owners and custodians of the country on which we meet today, the Ngunnawal people where I'm presenting from in Canberra. And I would like to pay my respects and acknowledge that they are the first navigators in this country, and we're very proud to be building on a long-standing tradition. I would like to pay my respects to the cultures and the elders past and present. So 6 years ago, the Commonwealth announced a major investment in a civil positioning program in Australia. And it was going to be making that investment to deliver on a vision that would see a transformation in the way that positioning was accessed in Australia, and specifically by improving the access to accurate and reliable positioning solutions. But before we go into the details of the program, I want to acknowledge that actually the vision that we're talking about was much older. The vision was developed around 10 years ago now, together with governments, industry and academia. And this really highlighted the need to undertake such a broad program. And that saw then eventually the Commonwealth coming on board and funding us to do that. And we have been leading that program in partnership with many people that I hope you will hear from and see today in the presentation. But before we go into the details of the actual program, I want to just explain a little bit why it's so important that we even talk about positioning and the need to have access to accurate and reliable positioning. So let me start on that. Now, I think most people will be aware that we can get position in a digital form through what most people would think of as GPS. So that's the specific example of what is more generally called a global navigation satellite system. And there are many of such systems. And in Australia, we're actually quite lucky because we can access solutions from a number of those systems that are circling the Earth at any old time. And this is the way that position is now really mainstreamed into many applications in society. When I'm presenting in a live room, we tend to kind of call out who of you has done anything from waking up with their mobile phone giving an alarm. I hope that's not at 2:45 a.m. for most of you. Have you been going for a run or a bike ride? Have you taken an Uber? Have you paid with your bank card or with your mobile phone? Now, any of those solutions are really applications of data that's delivered by GNSS systems. And I think if we look at our modern city or our modern society, it is very hard to think of sectors that aren't supported by data that are delivered through GNSS systems. So that goes from the electricity and the banking systems right through the traffic management systems, logistics and supply chains, building sites, the way we administer cadastral systems, down to Uber's taxi, aviation, and then emerging technologies such as Internet of Things or drone delivery systems. Really, PNT, as we call it, position, navigation, and timing, reliant on the GNSS signals, are everywhere, and that is only spreading. This talk today, I want to really focus on the positioning component, so we'll not be talking about timing. But even when we just focus on positioning, it is hard to think of a sector in society that isn't reliant on GNSS signals. And that goes from farming to rail to connectivity in terms of transport logistics, drones, handheld devices, on building sites in resources sector. Pretty much every sector benefits from these signals. And I think that's made possible partly because these devices are now quite cost competitive. There are 6.4 billion GNSS devices worldwide. They're really a mass market consumer device. And that means that if you were to switch off the GPS systems that deliver the signals for these devices, that would be a massive impact. So a study a little while ago estimated that if GPS, the American GNSS system, was switched off, it would cost about $1 billion to the UK and US economy alone per day. GPS over the time since it was declassified from a defense to a civilian system has generated roughly $1.4 trillion in economic benefits to the US economy. And another study estimated that over 10% of the UK GDP is supported directly by applications from GNSS. Now, I don't have the specific figures in equivalent for Australia, but I think what this highlights is that the way that we are applying GNSS applications across the economy is really broad and very, very deeply entrenched, and the benefits are hard to ring fence because they're so broad. And I think they're only just expanding as new applications come online. But there are some limitations to the way that we can use the standalone GNSS systems. There are some errors in the signal that limits their application. So at a very broad level, we see the satellites delivering the signal. Those are received by the receiver, the handheld device, or another device in whatever sector you're using it in. And there are some errors inherent in the way that signal is then translated into position. And they are compounding of errors that are inferred by the way that a satellite operates, so clock errors, orbit errors, some biases in the signal. There are then also interactions with the signal on its way to the receiver, so the delays through the ionosphere, the troposphere, and errors in the receiver, the biases and errors in the receiver. As a result, the GNSS signal has an accuracy of about 5 to 10 meters. And you would probably be aware of that. If you have called an Uber, you may have found that you were on the wrong side of the road, or the signal would jump around where it thought you were. So that's really a result of those errors. And initially, perhaps when GNSS was new, those errors were not such a big deal. It is so much better to have a digital position than none at all. But for many modern applications, that's really not good enough. And I'm just a really simplistic example here. If you look at the streetscape on the right, the grid there would give you the average expected error of a generic GNSS signal, knowing where the pedestrians are. So if the pedestrian were to use the signal to guide themselves, they could be anywhere in that block. That could clearly be pretty dangerous for them. They might not be on the crossing, but equally the transport, the vehicles in this case, could be anywhere in that block, and that could lead to collisions with other vehicles or with pedestrians. Now, there are ways to mitigate that kind of impact of the error, but you would have to include other sensors and slow right down. And when we think about GNSS as empowering productivity, efficiency, safety, and also innovation, then really slowing right down and having to work around that error really limits the way that you can use it to the benefit. And I want to give an example of where agriculture, precision agriculture, has really taken over the last 10 or 20 years, using the GNSS signals and correcting and having methods to correct on those signals to achieve higher levels of accuracy that really underpin the way that agriculture is now working. So precision agriculture, which requires centimetre-level accuracy, uses this to really guide its water and nutrient spraying. It can then minimize the pesticide application so that there's less runoff and less pollution, and it is the best investment from a financial perspective that it's put where it's actually needed. The same for application of other treatments. But agriculture also uses the GNSS signals for livestock monitoring or inter-row seeding, making sure that the heavy machinery is guided very precisely, minimizing the impact on the land that they actually working on. And it's integrating it with other sensors and doing enhanced yield mapping and controlled farming. But all of this really requires a better accuracy in terms of the GNSS signal than what they would get from straight GNS. So position correction has been around for a while, and in very generic terms, how that works is that the satellite signal is compared from how it's received on the ground from base stations, the continuously operating reference stations. These know where they are very specifically, very directly, and you can then work out the error because you can see what the station receives versus where it knows it is, and there is a correction model applied, and the corrections are then transmitted to the device. It combines it with the signal coming in to deliver a better estimate of where the position is than what would come from the signal straight. Now, that is cutting across a whole load of different techniques to do this. And each of those techniques has different performance in terms of accuracy, in terms of the initiation time, and the constraints that it has on where you need to be in terms of the ground infrastructure. So you can deliver the correction signal through internet or mobile, or you can deliver it through a satellite. And that second one is what we call the Satellite-Based Augmentation System, uses that technique. So it's really important to recognize that these techniques have been around for a while, and that the Positioning Australia program is delivering on a vision that makes all of these techniques more available and more accessible in Australia, so that the impacts of the efficiency and productivity, as well as the safety and the innovation, can be brought across the board for different users, because each of these users might choose a different technique because of the characteristics of that technique. So I hope that you can recognize this as we go through the actual program. So back to the program now, and this is where the showcase really kicks off. The Positioning Australia program was funded to the tune of, on average, 83 million per year on an ongoing basis to improve the access to reliable and accurate positioning solutions across the ones that I just mentioned on the previous slide in Australia. And the beneficiaries would be all of us, but they specifically would be delivered through industry and government to the public. It is really transformational because it is enabling across a number of components, and I'll go into these components in more detail, but at a high level, The first component, which is under the National Positioning Infrastructure capability, is looking at reducing the barriers to accessing and using PNT data so that businesses might maintain their competitive advantage in different industries that rely on positioning. So we'll look at that National Positioning Infrastructure capability, or NPIC, first. It is enabling centimetre-level accurate positioning across the country in those areas where there is communications coverage, so mobile phone or internet. At the core of the National Positioning Infrastructure capability sits an analytical capability, which we call GNAN, which is an open source tool and software kit, and we'll also talk about that separately. And then the last part of this showcase will look at the SPAS, the Satellite-Based Augmentation System, which is looking at improving the accuracy, integrity, and availability of satellite navigation at that sub-meter level of accuracy across the country and offshore. So I hope that at the end of this presentation, you have a sense of the value that Positioning Australia brings in terms of delivering the access to accurate positioning solutions across the country to the different users and the different use cases. This is a really ambitious program, and we've been going on this journey for about 6 years. So I wanted to just paint a little bit of the complexity and the ambition of this program with numbers. So in the past 6 years or so, we have procured 2 geostationary satellite payloads, which cover a footprint of over 30 million square kilometers. We have installed 2 uplink stations in Australia and then 2 more in New Zealand. We have driven over 100,000 kilometers to work on our national reference station network. We have 235 upgraded stations across the country, and we also are working with 500 third-party reference stations as part of a national network. We are at the moment delivering services to over 6,500 registered users, and we're tracking 4 global navigation satellite systems, so 4 GNSSs and 2 regional constellations, or RNSSs. We have one amazing GNSS analysis software suite that is delivering over 3,000 real-time orbit and clock corrections per day to the tune of around 15 terabytes per year. We are delivering 8 services operationally at this time, and better services or service improvements to come into the future. I'll tell you about that later. We have over 20,000 connections to those services, and many of those are then on-selling those to value added to their customers. And early open services from satellite are available at sub-meter accuracy with over 99.5% availability. So just to sketch you the sheer scale and complexity of this program before I dive into the detail. Our services are right across the country right now and offshore. We are delivering accurate and reliable open services that can be used to deliver that centimeter level positioning across the country for use by government, industry, academia, and the community. All right, I hope that set the scene at the big picture level, but now I'm just like to take the opportunity to go into a little bit more of the components of this program and showcase the value that they bring to that vision of making accurate positioning available in Australia. And luckily for you, you don't have to listen to me all the time. I'll bring in some of our delivery partners, and I want to bring in some of our users to just tell you what this program does for positioning in Australia. Just to kind of highlight, we will start by talking about the National Positioning Infrastructure capability. So that is this component here on the left. It is enabling 3 to 5 centimeter accurate positioning services in areas with connectivity, so mobile phone or internet coverage. And it really delivers on the vision to unify Australia's positioning infrastructure, because that is one of the main ways in which we're seeking to reduce the barriers to accessing and using PNT in Australia. And this allows Australian businesses to maintain a competitive advantage and deliver their services and keep on innovating. So let me give you an insight on how the NPIC, or the National Positioning Infrastructure capability, does this. So I'll do that by letting actually one of our partners from the Victorian government explain that to you.
G'day there, my name's Hayden Asmussen. I'm the manager of the Victorian Government's GNSS reference station network called GPSnet. Our GPSnet operations team works closely with Positioning Australia in the ongoing maintenance and enhancement of the National Positioning Infrastructure Capability, or NPIC, here in Victoria. It's through the NPIC that we can enable precise positioning services throughout the state. NPIC also allows GPSnet data to be made freely available from more than 130 GNSS reference stations, or more commonly known as cores, here in Victoria. Commercial partners can connect to these reference station data streams to deliver GNSS correction services to all their customers relying on precise positioning for a wide range of applications, not only here in Victoria but also nationally and internationally. And look, NPIC has helped increase the capability and accessibility of precise positioning services to users, whether it be on a new housing estate subdivisions, whether it's on the farm, it's out in the bay behind me here, flying over bushland with drones, or even on Victoria's big build construction sites. End users may not really realise it, but NPIC is the infrastructure that makes precise positioning services work here in Victoria.
So that was a really great explanation of what the NPIC, the National Positioning Infrastructure Capability, delivers. So by establishing the NPIC capability, we are really operating a national approach, a unified network of positioning infrastructure. And that is not just the actual physical infrastructure across the country, and some examples are there on the right, the actual reference stations, but it also includes a modern digital delivery platform, which is a way in which we can improve the performance, availability, and security in which the data is then disseminated. And at the core of the National Positioning Infrastructure Capability sits the Analysis Center software known as GANAN, which I'll tell you a little bit more about in a minute. Before there was the national network, a unified national network, there were many networks across the country. And given the size of Australia and the way that the population is distributed across the country, there was a real impediment to delivering services across the country because the investment in infrastructure was so cost prohibitive. And this was a problem for people who tried to deliver services, and it was that problem is then passed on, obviously, to the stakeholders and customers of those services. So by joining the networks together and bringing a unified, high-quality network, the access barrier to accurate positioning opportunities is really lowered, and this has benefits for everybody in the ecosystem that delivers the positioning services and the users of those services. So I'm going to give you an example of one company that has taken the opportunity offered by NPIC to bring an innovative service into Australia. And then hopefully that gives you a real demonstration of how NPIC can develop and deliver value for Australians.
Today we're viewing a demonstration from a company, Tiny Mobile Robots, who are going to demonstrate how high accuracy positioning can be used with their robot to mark out a sports field.
So the Tiny Mobile Robots are an autonomous line marking robot. They're unique because of their accuracy. Once we've set up a ground, we're able to remark that ground within 1 centimetre of accuracy every time we mark the ground.
Geoscience Australia is here today to see how our positioning infrastructure is being used by companies like Aptella to deliver centimetre-level positioning solutions.
With this sort of technology, we can support people where they can't do their work with more efficient, more safe and more effective practices.
Global navigation satellite systems, such as GPS, provide accuracy of around 5 to 10 metres. There are, though, many users out there who require more accurate positioning. What the National Positioning Infrastructure Capability does is it makes data streams available from ground-based reference stations that can be used to correct some of the errors in the GNSS signals. Tiny Mobile Robots are a really good example of how high accuracy positioning could be used because they need to draw really straight lines across a somewhat rough environment.
With NPIC, there's no need for people to invest in their own base stations, so service providers like us can provide uniform corrections right across the country in a cost-effective way.
Without that infrastructure, without those networks being available, businesses won't be able to operate like ourselves. So it's absolutely critical that we've got that infrastructure and we've got it Australia-wide.
Technology is becoming more and more part of our daily lives. We're seeing drones deliver packages, we're seeing autonomous vehicles being trialled on our roads. Robots like the one being demonstrated today are being used on farms, they're being used in mines, and they're being used on construction sites.
Geoscience is really leading the way in Australia to make sure we've got the accuracy, we've got the quality, and we've got the reliability that Australian businesses need to use their high accuracy positioning services.
This kind of innovation, through geoscience is just critical for anything in the robotic industry, really. The satellites will get us to a certain distance, but without this kind of infrastructure, we have no chance of getting to 1 centimetre. So it's critical. If we want to operate a business, we need access to these kind of networks.
So I hope this little video of the tiny mobile robots has given you a very good insight and explanation into the value that the National Positioning Infrastructure Capability delivers as part of the Positioning Australia program. So really that value can be summarized by saying that if you deliver and invest in a unified approach to managing a national positioning infrastructure, it means that we are ensuring consistent, fit-for-purpose data, and that now, as a result, this is underpinning Australia's geospatial fabric in many ways. It even improves, helps us define and deliver the national datum, which underpins the broader spatial capabilities in Australia. The NPIC supports research and encourages innovation, as you just saw an example of, by opening the access to data, products and services for industry and for their users. And it has become a very powerful platform for Australian businesses to strengthen that sector in Australia. So I'm just taking the opportunity to let you hear from some of our stakeholders and users who will explain what the National Positioning Infrastructure Capability has meant for their business model.
Hi, my name is Linda McGregor and I'm one of the directors of MondoPin.
Hi, my name's Namo and I'm a network manager at MondoPin. So yeah, thanks to the team at GA, that expertise has allowed us to trust the quality of data that we're given. That coverage has been expanding a lot, allowing us to expand to the whole of Australia, serving our clients in all states and territory.
Yeah, the communication between GA and us as well as a supplier in our VRS solution has been very good as well.
That team has been very helpful to us. We are able to provide feedback and yeah, they're very responsive in implementing the change that is necessary for us as well.
Yeah, and we're also helping them as much as possible improve the network and give them ideas of where it can be improved.
So who is using the National Positioning Infrastructure at the moment? We have, as I said earlier, over 6,000 direct subscribers. Of course, many of them with their own customers. And in broad buckets, we see a split where 40% is within the geospatial and surveying industry, and then a big chunk in agriculture, research and development, very important for that innovation component, and mining and construction are additional buckets. So this is a real indication of where the centimetre level accuracy that and national positioning infrastructure capability enables, where that is bringing the value. An independent study undertaken earlier last year by Acel Allen estimated that in 19 years of operation, NPIC services would contribute over $500 million to the Australian economy. And the real drivers for that number come from the sectors of agriculture, mining, construction, surveying and geospatial. But we think that the innovation component, we're very excited to see if that innovation component will change those numbers that we anticipated here and open up new sectors that may also contribute to the value that NPIC delivers. Just to close out our discussion on the National Positioning Infrastructure Capability, we'll hear from one more stakeholder who talks about what the value is that NPIC delivers for them.
Hi, my name is Mike Horton. I'm the project creator of the GeoNet Foundation. GeoNet is a Web3 geospatial network. We provide high accuracy positioning services for applications in IoT and consumer. We utilize blockchain technology to ensure the integrity of our global network, which now consists of 10,000 plus RTK base stations. We've had a very positive experience collaborating with the team at Positioning Australia. Positioning Australia has supported our network with station infrastructure in Australia and New Zealand. Positioning Australia has also provided the open source GNON code, which we have been using in the development of PPP and PPP RTK services utilizing the GeoNet station network in combination with the Geosciences network. Deeply appreciated all the help and look forward to future collaboration.
Well, that's a brilliant segue to the second component that I wanted to highlight. As I mentioned earlier, at the heart of the national positioning infrastructure capability in the way that we are delivering this sits an analytical engine, which we are very proud to be able to call GNAN. It's a software suite of open source tools, a software that will help us deliver the positioning and navigation services. It can also be used outside of the context of the Geoscience Australia as a standalone tool for innovation. And that's what I wanted to just highlight in the following segment.
Groundbreaking Australian technology is making precise location data even more accessible thanks to GNAN, a global navigation satellite system analysis software that delivers real-time corrections and additional products as an open-source toolkit to enable precise point positioning. Using GNAN, Geoscience Australia is delivering real-time, no-cost access to centimetre-level positioning, supporting the development and integration of solutions for industry and government.
We have a platform out here on Googong Dam, and we're using it as an experimental station to deploy a whole range of different instruments, including the GNAN GNSS positioning device. Accurate satellite information is critical for national and global assessments of water quality and the prediction of water quality impacts from climate change. Understanding the position that we have is really critical. GNAN gives us information that improves our capability to make these assessments.
To achieve this, Frontier SI deployed GNAN in a box, purpose-built demonstration test kits designed for integration with CSIRO's Googong research platforms. Teams from GA, Frontier SI and CSIRO examined the performance of GNAN in a long-term test scenario. Not only did GNAN achieve centimetre-level accuracy through post-processing, it also demonstrated the potential for centimetre-level accuracy in real time. This successful deployment proved that GNAN is a capable, open-source option for water level determination, ready to be adapted for exciting and innovative R&D challenges.
So at the Googong Dam demonstration, we wanted to show how GNAN in a box could be deployed in an edge compute environment. GNAN uses cutting-edge scientific algorithms to really accurately determine both the horizontal and vertical motion of the platform. One of the drivers behind Positioning Australia is establishing the infrastructure and systems to enable Australian businesses and researchers to innovate. We've taken GNAN and GNAN in a box and we've bolted it to a drone up on the reef. We've flown it on a balloon. We've now floated it on a platform on Googong Dam. What we're really interested in is what you can do with GNAN in a box. Use the instructions, build GNAN in a box and apply it to some crazy, innovative, amazing positioning applications.
So I think this video is a really neat demonstration of the applications of GNAN in new and novel ways. So the value that we see GNAN as bringing to the Positioning Australia objectives in its own right, outside of the context that it's applied in the national positioning infrastructure capability, and within that, it is acknowledging that really those are brought by the fact that it's a world-first open source multi-GNSS analysis software, and that is something to be very proud of as it's developed in Australia by the team here. It enables accurate positioning and it delivers an all-in-one solution for real-time centimetre-level positioning where there is communication coverage and post-processing of precise positioning where there isn't communication coverage. Within the context of the national positioning infrastructure capability and other applications in Geoscience Australia, we get a lot of value out of GNAN because it allows us to validate and verify the quality and performance of the GNSS networks, and it can do so for other users as well. It creates open GNSS SSR correction services that support science and innovation applications. And it supports for us the development of reference frames and studies in crustal deformation, atmospherics, and environmental monitoring. Really, GNAN in its own right enables innovation. It allows new applications of centimetre-level positioning without the need of some of the RTK-style infrastructure, and it offers complete functionality that can be easily integrated by users. And just to underscore this last point, I'm going to play you a testimony of one of those users who's telling us how he is using GNAN.
My name is Louis, and I'm the co-founder and CEO of Lura Systems. We're a startup from RMIT Activator in Melbourne, and we specialize in geospatial services and precise positioning. I believe Geoscience Australia's NPIC approach is a blueprint for scientific data sharing and for industry cooperation. I've been using their services for the past 10 years, and we use GNAN today to process GPS data and data from other satellite systems, or GNSS. GNAN brings the latest research in multi-GNSS and makes it available in an open source toolbox. This capability is typically reserved for few research teams, governments, or big companies, and today it's part of our location tech stack. I believe with the growing demand for location services, GNAN and Positioning Australia will have a much broader impact.
So to conclude our section on GNAN, I wanted to give you a demonstration of what GNAN looks like in action. And to do that, I'm going to put my hat on because it's sunny here, and I'll head outside and show you what it does. So why am I out here wearing a funny hat? This is to demonstrate what GNAN looks like in action. So GNAN is an open source toolkit. It's a very innovative piece of homegrown analysis capability. It helps us analyze in real time the data streams that come from the NPIC stations across the country. And it generates the products that we need for positioning, such as satellite, clock and orbit products. It also in real time models the errors that we need for centimetre accurate positioning. GNAN is now in its third iteration, and it is gaining traction and adoption both domestically and internationally. So while I've been walking, GNAN has been modeling my position to centimetre level accuracy in real time. And this demonstrates how a single board computer and a modem, an uninterrupted power supply and a GNSS receiver are all that's needed to allow GNAN to deliver centimetre positioning in real time. And that concludes the section on the National Positioning Infrastructure and GNAN, which is the component of the Positioning Australia program that really tried to open up the way that positioning opportunities were available to industry to deliver onto users, enabling that centimetre level positioning. And we're now going to go to the final component of the presentation today, where we're looking at a different way of delivering centimetre or sub-metre level positioning services across Australia. And that is the first Southern Hemisphere Satellite-Based Augmentation System, better known as SouthPAN. SouthPAN will deliver comprehensive positioning, navigation and timing across the continent and offshore to accuracies down to as little as 10 centimetres. And it's delivered in partnership with Land Information New Zealand. So it is an initiative of the Australia and New Zealand governments together. And to give you an introduction to SouthPAN, I'll play you the last little video today.
Where are we going? Where should I put this? Where should I start? Knowing where is key to connecting all of us. It helps us plan ahead, helps us find our destination, helps us get there safely. Knowing where is now a whole lot easier with SouthPAN. This satellite-based augmentation system is a joint initiative between the Australian and New Zealand governments. SouthPAN improves location accuracy across both countries and their economic zones, from 5 to 10 metres, to less than a metre, down to as little as 10 centimetres. This precise positioning unlocks a world of capabilities across multiple industries, from more efficient supply chains to safer work sites. Precision agriculture for better productivity, and getting your delivery to the right place. If you need to know where, SouthPAN can take you there. Early SouthPAN services are available, open access and free. Visit the website to learn more.
So, as you saw in the little video, how an SBAS system such as SouthPAN works is that the corrections to the position are delivered not just by the internet, as we are doing at the moment already, but they're also uplinked from a ground uplink station to a satellite, and they're then disseminated through that satellite. And that means that the ability to get that accurate positioning is not reliant on being anywhere close to communication infrastructure such as mobile phones or internet. It is accessible anywhere across the country and also offshore. And this means that these services from an SBAS system such as SouthPAN are really useful for a range of applications that rely on that ability to have access to that signal wherever we are in the country, and especially in a country such as Australia, which is so large. There are other components of SBAS that make SouthPAN such a strong contender for the value that it delivers, and this is in its high level of reliability, which is because it is a very strong system. It is engineered to a very high level of redundancy, which means that the services are guaranteed to a very high level of availability. So if we want to summarize the value that SouthPAN contributes in Australia, is that it delivers reliable and accurate positioning without the need for mobile phone or internet. All users in Australia and New Zealand will have access to the sub-meter positioning solutions anywhere and anytime, with full coverage of open services independent of existing telecommunications infrastructure. And therefore it can increase productivity and efficiencies across sectors such as resources, agriculture, transport, maritime, geospatial, and to be honest, any other sector that we think about. With services currently at 99.5% of availability, we are working towards full operational capability around 2028, where they will be at 99.9% availability. And then in that around the same time, one of the services will be guaranteed or certified for safety of life applications in aviation, which is a really important factor in the value that SouthPAN will bring in Australia and New Zealand. And at the moment, that is an aviation service, but we think safety of life will have increased meaningful contribution to other sectors that rely on really important safety of life applications. SouthPAN services are compatible with other global similar systems, and that is a very strong component of the value that it brings. I will now play you a little testimony of one of the users of SouthPAN that tells you what SouthPAN means to their business.
My name is Peter Terrett, and I have been using GPS for over 38 years. In 1991, I went into business to sell, support, train and consult on GPS, and since that time we've sold many thousands of GPS into a variety of industries. The recent innovation that we have in this region is called SouthPAN. It's the Australian and New Zealand's satellite-based augmentation system, and what that means is sub-meter accuracy anywhere across Australia and New Zealand. It has been a boon to people like cultural heritage and archaeologists who are mapping Aboriginal artefacts, where legislation in a couple of the states says it has to be to sub-metre accuracy. I'm Peter Terrett, 4D Global, and that's what I have to say about SouthPAN. It's an absolute gift.
So Peter just referred to the application of SouthPAN for purposes such as cultural heritage mapping. As he said, that is required the level of accuracy that standalone GPS cannot achieve, and often is undertaken in really remote regions where installing ground infrastructure would delay and bring extra costs to the ability to move in and undertake work efficiently. So here is where SouthPAN is being used to deliver efficiencies and productivity that is really what that was envisaged when we went down the road of working on an SPAS. We've also been working with Frontier SI with some of applications in the maritime sector, where the sea pilots around Victoria have been trialing out SPAS for the ability to track where the ships are going, where again, centimetre level accuracy is really important, or sub-metre level accuracy down to centimetres is really important for the ability to track and navigate around heavy ports where investigation and training require continual tracking of where ships are, as well as the actual ability to navigate itself. And these services can really change the way that they operate around an area by delivering efficiency improvements and an ability to manage without potentially having to jump between networks. And the final application I want to highlight here is where a forestry operation in New Zealand, in this case, has been using SouthPAN to deliver their work more efficiently and more streamlined. Is they have really brought down the way the time that it takes for them to undertake their work, both in terms of taking field surveys and then also using drones to operate in a forestry context where standalone GPS would not give high enough levels of accuracy. And the operations that they have been doing have really shown them the benefits allow them to improve their efficiency and their productivity by having that accurate signal available with very little need for post-processing. An independent study was undertaken a number of years ago based on the testbed that we ran for 2 years with an early version of the SouthPAN system. At that point was called a testbed. And based on that work, an estimate said that SouthPAN would contribute up to $6.2 billion to the Australian economy over 30 years. And this is based on those benefits from efficiency, productivity, safety, and innovation right across the economy, with many very great examples in that report. So I hope this has given you a bit of a sense of how across the Positioning Australia program, we have sought to bring access to accurate and reliable positioning, different solutions to Australian industry and governments and their users. And we hope that we have given you a sense of the kind of innovation and new business that we can see back on the back of this investment and the value that has brought to our customers and their customers. The services of SouthPAN are available now. There are 8 of them available now. So please head to our website to find out more information about the characteristics of these services and the definition of how you might start using them. This is not the end of the program. We're only just after the establishment phase. We're going forward. We are really busy upgrading the way that we can support our services to the users. Better documentation, improved performance monitoring, better outage notifications and support tools. And of course, as I mentioned, we're also continuing to improve the way that SouthPAN services are delivered in terms of accuracy and availability, with the culmination in the Safety of Life certification by 2028. And really the benefits of positioning come from our perspective when these services are combined with other services in the kind of digital economy that we see developing all around us, be it a digital farm or a digital city. It's the combination of these services that the true value is being delivered through. I just want to close this presentation by saying a program as ambitious as Positioning Australia is not delivered in isolation. There are many, many partnerships that have really been part of the way that this program was conceived, but then also delivered. And we've put them in alphabetical order. I hope you can see the different ones either on the pictures or on the left, but there are many more stakeholders and partners that have been part of our journey. And we look forward to working with other ones as we go forward. And the final slide, I hope you take away at least from this very presentation that P&T is really, position, navigation and timing is critical for our society and our economy. And we are, with Positioning Australia, establishing a world-class capability in Australia with services available and operational now, continent-wide, consistent, high quality and open source. We are hoping to enable government, business and industry to use those positioning to deliver productivity, efficiency, safety and innovation. And we are going to keep on supporting people who would like to use our services. And look forward to hearing from you. And you can do so now through the question. Thanks very much. Steve, back over to you.
Thank you, Martine. Yes, we've got about 5 minutes for questions. If you do have a question, rather than raising your hand or putting it in the chat, we've got a Q&A section that is a drop down at the top of the page. And if you add your questions in there, I'll be going through them to get things going. But hey, before we go any further, Martine, thank you. You've very succinctly taken us to the cutting edge of innovation, service delivery, science. That was really exciting. So everyone, please join me in thanking Martine. Well done.
Thanks, Steve.
Just while we wait for people to type in the questions to the Q&A section, I just want to ask, I'm going to ask you a real addictive question, right? You've got me addicted to the cutting edge. And I wonder, I know you keep an eye on the future and how this can be sustained onwards. What do you think are some of the big frontiers that maybe will be coming into this field in, say, 10 years' time? What are some of the little fledgling things you might see now that we'll be talking about then?
Well, that's a really excellent question, because that's, of course, something we do need to keep an eye on to remain relevant. And I really look forward to working with our stakeholders, which is something we hope to do over the coming year to make sure that we understand what our stakeholders think are the developments that they're keeping an eye on. But from my perspective, I can see a few big strands developing around the positioning world. One of them is a real growing, and this is globally, I think, concerned to really understand that the way that P&T applications are pervasive through our society, and what we need to do in terms of monitoring and being aware of what it requires in terms of resilient systems. So that's something we'll keep an eye on, and government has a role to play there. I think the other one is the emergence of quantum, AI, and combinations of opportunities offered by, say, LEO, etc. Different ways of developing and delivering services to really augment and broaden the way that these positioning solutions can be integrated and then delivered to the customer. So I think that's a very exciting landscape to watch, and I don't expect in 10 years positioning in Australia will look in the way it looks now.
Yeah, that's terrific. Yeah, thanks for that, Martine. We've got a couple of questions actually from people outside of GA, which is great to see that engagement. I'll start off with one that's come in from Jonathan Nally, who I think is well known to many of you. Firstly, thanks you for your presentation, and interested to know a little more about the status of the next satellite payload and what stage is the procurement up to.
Yeah,
Martine, are you
thanks.
happy to talk about that? Yep.
Well, I'm happy to say that I can't talk about it as the rules on procurements in the Commonwealth unfortunately preclude. Suffice to say that we are running a procurement for that second, or in fact third payload, because there's one payload up already. And we will be announcing that publicly through the usual channels, Jonathan, as soon as we ever can. Thanks, though, for the question.
Yes, I detect eagerness from Jonathan there, which is great to see. And
so are we.
Stay tuned. Another one that could be a little similar, this one's from Lynn Terrett, and she wants to know, when will safety of life certification be finalised. I guess, yeah, there's a lot to go on there, but if just a commentary on, maybe where that's at and where it's to go to.
Yeah, we are working very actively with Air Services, CASA, and with our partners on that side in New Zealand. And we are envisaging that to be in 2028. That is the current time that we're aiming for.
Yeah, terrific. Okay, here's an interesting one from Robert. Robert Hines or Hines. Sorry, Robert, if I didn't get the emphasis right there. But just asking around GNS failing, did it fail completely in the USA during the geostorm or the solar storm that we had this year? And maybe if you could say, I know you do think a lot about this, about solar weather and how that fits in here.
Oh, absolutely. Yeah. So we did it. We didn't see the level of failures in Australia. I shall say that up front, that the US experienced in the solar storm, not the most recent one. I don't know the details about that, but the one a few months ago, there was a solar storm, and we do have reports of the systems being really hamstrung and possibly really failing. I don't know how complete that failure was. I do know that the quality of the services really degraded, but it's important to say that the systems such as SPAS systems, where they're safety of life certified, have automated integrity monitoring as part of that service. So the users of those services know whether to trust them or not, despite the solar activity. So for instance, the WAS system, the SPAS in Northern America, was not able to be used, but the people who would rely on it would know that it wasn't able to be used. So solar activity is something to monitor for, and that's something we're thinking about, how we can improve the way that we support our users and their users on the impacts of solar activity. But something like a SouthPAN system already has that built into the way that the services are delivered to their users. Thanks.
Excellent. Thanks for that, Martine. I've got 1 minute left for questions, and we've got one question there, so I'd love to clear the sheet. And this is from, it's one from within GA, it's from John O'Ross, and he's asking about the emergence of big LEO, so low elevation comms constellations like Starlink. What will that open up with new opportunities for service delivery and impact?
Yeah, I think that's a really interesting one. There are opportunities to use these systems to deliver some of the correction signals. So again, it is broadening the way that different correction techniques can be delivered with the users. And I think from the perspective of resilience, diversification is always one way to improve the resilience of the broader systems. Although they themselves might have other vulnerabilities, I'm not conversant enough to comment on that. But I think it is really important that as a country, we understand how the ecosystem of different techniques, different options, different modalities of delivering them is helping our users really get the benefits of positioning going forward.
Yeah, great answer. Thank you, Martine. That's actually clocked over to the time that I need to now start wrapping it up according to my instructions. So thank you again, Martine. That was fantastic. And thank you for taking those questions. They were great answers, actually. I found they were quite inspiring and thought-provoking in themselves. So thank you again. And look at all those hands clapping and flying through the air. Thank you also to everyone who attended today and participated in the Wednesday Geoscience Australia seminars for 2024. We had a great program this year. They will be back in 2025. And in the meantime, keep an eye on the ga.gov.au events page for other public events and also the rejoining of these seminars. And you can also visit past seminars on our YouTube page. And I think that's a great resource. So anything you missed, or just say you want to hear Martine again and again, you can do it through YouTube or pass it on to your friends for them to see it. So thank you, everybody. Thank you, Martine. Have a great day. See you later.
Thanks, Steve. Thanks all. Bye.